welcome. As he said, my name is David Aktary. Talk to you a little bit about full stack serverless development. First question though is how many of you attended Christopher's talk this morning? Okay, we will be covering some of that stuff as well. Just to be fair, I want to give you some fair warning that there is some overlap in some of this because there's only so much ground to cover, but we are going to also go hands-on towards the end of the talk. My goal there is really just to get you comfortable getting your hands dirty with Lambda or with serverless, but specifically Lambda, so that you can take that back to your place of work and see how it might apply to what you're doing. So quickly, we are going to have a decent overview of what the options are out there as far as serverless. Really, what does serverless mean? Because it means different things to different people, and the definition has changed over the years. We're going to talk about why you might want to do serverless. Christopher touched on that a little bit, but I think it's important to take a look at some of the details and see how you might decide whether or not it's a good approach for your architecture. And then we're going to look at some of the platforms and the tools and things like that you're going to want to use or potentially use. Next, we're going to move into some of the specific issues that you're going to run into when you actually go to implement this and how you might go about approaching a greenfield build as opposed to a migration, because those are going to be two very different things. Then one of the big issues I think in this area is impact on developer workflow and how that can be addressed and what the tools are out there that are trying to address it right now, and what the deficiencies are. Finally, there are a couple of pitfalls and gotchas that you need to know about before you make the decision that this is the approach you want to take. And then we'll finish with the workshop where we actually get hands-on and get practice actually taking an N-tier application and starting to move it into the serverless framework. So a few caveats before we really get going. This space is changing almost daily. There are new tools out there being introduced all the time. Amazon has recently introduced a lot of new tooling around how it handles things like deployment of infrastructure. They have a whole new tool called SAM that is a sort of an extension to CloudFormation that if you're thinking about doing this and you're not going to use one of the frameworks to do your deployment, you should really take a close look at SAM because it makes life a lot easier than doing CloudFormation type deployment. Another thing is this is going to be AWS focused. We're going to talk a lot about AWS today, mostly because it's most mature. There are a lot of interesting offerings out there that are being brought about that we're going to take a look at, but AWS is by far the most mature. I don't think that's a surprise to anyone. So we're going to be focused a lot on Lambda. This is not exhaustive. This is basically just me caveating that I've already caveated a little bit. It's rapidly changing. When I talk about some of the things that are out there as far as the frameworks that support serverless or some of the tooling and all of that, there will be other things out there that may fit your needs better, so do your homework. But I'm just trying to highlight some of the what I've found to be the most helpful or important tools to use. And finally, we are a JavaScript shop where I work, and so we are JavaScript focused, so a lot of my examples will be around Node and the JavaScript stack. So I apologize if that's not to your liking. For what it's worth, if I get any street cred, I did start out in C++ and Java and eventually ended up here in JavaScript. So I don't know if that buys me anything. Briefly, who am I? I did my computer science degree at Michigan, did an MBA at Duke. I actually spent about 10 years consulting to the automotive industry, 8 of which was with IBM. I did a detour through advertising, which is a very interesting world if you ever have a chance. I actually have worked on a music video with Snoop Dogg, randomly, which has nothing to do with software architecture. But I eventually found my way back into really hardcore technology. And as the founder of my development shop that's based in LA and Austin, I end up being sort of the de facto chief architect. I don't use that term, but Bill Gates likes it, so. That's pretty much it. We do custom software development. We do consultative work. We do focus a lot on smaller startups and the technologies that they use so that we can then take those and apply those to some of our bigger clients. We work with Universal Music Group and Qualcomm, USA Today. And so we're trying to bring those technologies in, and serverless is one of those technologies that we're doing that with, which is how I ended up here today. So let's start off by defining what we mean when we say serverless. It used to mean a backend as a service or a mobile backend as a service, where it was very purpose-built and it was just a third-party API that you called or whatever, and it just did a specific service. Nowadays, most of the time when people are talking about serverless, they're talking about function as a service. It is your custom software that you define, and that gets deployed, and that's the serverless application that you're talking about. They do have some similarities, right? That's pay as you execute. They auto scale. You don't really have to think about it too much. It abstracts the infrastructure from the code execution, and it's all managed under the covers and whatever. But mostly, when we talk about this nowadays, we're talking about the function as a service. So the various providers out there offer these services. Google Cloud Functions, we'll see a list of them later. Amazon, all of those. Break down the way that they think about these things into three main pieces, and the frameworks do this as well. It's functions, which are the code that you've written, the triggers, which are the events, as you can see here, kicking off a function, and then the resources on the back end that are used by that function. Resources can be another function. So it can grow your topology of your application quite large. If you've got a lot of functions calling other functions or queuing up messages for other functions to then get kicked off with, because that's a trigger, by dropping a message in that queue, that triggers another Lambda, it can actually grow quite broad. But in the end, they all kind of fit into this framework. So what does that look like in practice from an actual architecture standpoint? Martin Fowler gives these two examples in his discussion of how you might take an n-tier application and break it out into a serverless application. Those of you that attended Christopher's talk might recognize this architecture and the API gateway sitting in front of a function that then reaches out to the backend resources. Message-driven application looks pretty similar in a serverless environment. I think the big difference there is that you've got these scaling click processors. It's not a monolith. It's just these single functions that are going and managing the clicks for you. So why do we care about this? What is the benefit? Why would you want to do this? My argument is that cost is one of the biggest drivers, if not the biggest driver. And Bustle, I was at Node Interactive in December of last year, and the CTO of Bustle, who's heard Bustle, anybody? It's a large women's lifestyle website. I'm top 100 or so women's website, and he was completely sold on this because it allows their engineers to not have to think about scaling. It allows them to just simplify their job down to just the code level. And they can actually cut their staff, and they did cut their staff. But the most impressive thing to me was this 84% cost savings measured at the server level, where he said that essentially they had one application that they had server costs of $2,500 a month. And after moving to a serverless architecture, that went down to $400. Now, at scale, that is really impressive. That is something that if it fits your use case, can really drive a lot of value for the business. So if you want to figure out if this might make sense for you, I encourage you to check out the serverlesscalc.com and put in some of your own use usage patterns and some of your own configurations as far as what does what size of resources you would need, and see if it makes sense for your organization. My suspicion is it very well could. Just driving at the cost piece a little bit further, you can see that under the right conditions, you can get 1/10 the cost of an EC2 instance under the right conditions. Similarly, for a periodic job, now this is for a website, but if you have a scheduled job, you're still potentially down to 1/3 of a T2 Nano. Like those are really compelling, right? This is the kind of stuff that gets management's attention. So just to beat this horse a little bit more, but to give you some performance examples, if you were to say, let's take a look at a large, M4 large, and understand that generally costs about $86 a month, what kind of performance could we expect? Or what would we have to be hitting a Lambda with to get roughly the equivalent cost, right? So you could have a Lambda running for 1 second at 1 gig, 1 full second, 1 gig, and serving 2 requests constantly, and you would end up with the same cost. You could similarly have just 100 milliseconds at 120 meg and serving 82 per second. So that might help you kind of size out, does this make sense for me or not? You have think about what kind of resources your application uses and kind of do the comparison there. Does that make sense? Yeah.
Clearly, serverless, so it's pretty basic question. You talked about why
Let me grab you the mic.
serverless.
Check that.
Stats was showing.
There you go.
Check that. Yeah, there you go.
I'm trying to understand how is it getting this? How is it achieving this? The basic of.
Okay. Thank you. I did gloss over that. On a couple slides back, I believe it said that you're only paying for execution. So unlike an EC2 instance where you're paying if it's getting load or not, with Lambda, you only pay for execution. Okay. Now there are ancillary costs that you have to consider if you're using other resources, right? If you're using a database service or if you're using other services, those will generate costs as well. But that has to be worked into the picture too. So another consideration beyond cost is that it helps drive 12-factor adoption. Is everyone familiar with 12-factor? I'm hoping. This is a framework put together, I think, by the Heroku guys. Just that kind of defines or helps provide guidelines for how good software should be built, right? The nice thing about it is it takes a lot of the variability and a lot of the responsibility away from the developer and just has it built into this sort of ecosystem. So it's actually, this is a very interesting analysis. I encourage you to check this out on the IBM site, because there are a lot of ways that you can write bad software, and by eliminating the possibility from the developer having to make those decisions, it can save a lot of heartache down the road. So let's talk about platforms and tools. Shouldn't be any surprise to anybody that all the big boys are getting into this. This is the latest buzzword for all the big players out there. Amazon Lambda is, of course, the granddaddy of them all. It's been out the longest and has, as I said earlier, matured the most. I would say that's followed closely by Azure and Google Cloud Functions. I've heard some complaints about the layout of the Azure UI, but at least with our workflow, we don't use the UI very much. So maybe that's an issue for you, maybe it's not. You also have the option of not going with the hosted solutions, right? You can try to roll your own. And there are frameworks out there that'll help you do that. And you may have some institutional reasons why you have to do this. You can do it on-prem, you can do mixed-prem. But these are some of the tools that might help you do that. One key differentiator here with some of these guys is that they claim to minimize vendor lock-in because you really are kind of committing. If you go with an AWS and you really want to buy into the whole serverless concept and construct, you're going to be using all of their ancillary services, their SNS and all the various database services and all of that. And that kind of gets you necessarily locked in, right? So you have to be ready for that. Some of these other open solutions claim to not have that problem. We have not deeply investigated that, so use at your own risk. Also, I highly recommend this awesome serverless list here. If you have a chance to check that out, the tools that are there and the breadth of knowledge, they keep that up pretty well. So as this space continues to evolve, you can continue to reference that for different tools and things that might be of value to you. This last one, by the way, Funkatron, is not only handling the serverless execution piece of it, but it's also a sort of framework, and we're getting into frameworks in just a second here. So it kind of straddles the line there. If you do want to roll your own, this is what you're looking at. It's not nearly as simple as in our case, a single API call that just throws something up onto AWS and we don't worry about everything going on underneath, right? You've got a lot of coordination, a lot of tooling that you're going to have to put together. And I'm sorry, this is a bit of an eye chart, but that was kind of the intended effect. This is not an easy thing to do on your own. So do it if you need to, but make sure you have a damn good reason because there's a lot that goes into it. So I strongly, strongly recommend that if you do go down the serverless path, you choose a framework to use to help you along, because it is incredibly laborious to do this purely through the UI or by hand with AWS commands and things like that. As Christopher did this morning, I will also recommend the serverless framework, the unfortunately named serverless framework, because it just takes care of a lot of the details for you that you don't necessarily have to do on your own. I tried to break this out. This is something we produced originally because there are some clients that are interested in other languages besides Node.js, so they want to know what frameworks support those languages. Also, a major use case for us, because we do a lot of things that are, traditionally would be considered sort of end-tier web type things. API integration is important there, so you want to consider, if you're going to be doing that sort of architecture, making sure that the framework that you choose supports that integration and does so in a easy-to-use manner. Any questions so far? No. Okay. All right. So serverless in practice. Basically, how would you approach this if you're going to do it greenfield? As you saw on the previous slide, you kind of need to get the basics out of the way first, right? Choose what language you're going to use, what frameworks you're going to use. Identify what your triggers are, what events, and what resources are going to be used in the background. If you're migrating, well, this is a greenfield, so never mind migrating. But think about which database makes the most sense for you. Obvious things for this audience, architects, I'm sure this is probably basics, but this is pretty much it, right? However, if you're refactoring, it gets a little bit more complex. So if you're refactoring and you're doing a migration from an existing end-tier architecture to a serverless, there are things you need to consider. First, your environment variables need to be handled appropriately. And as Christopher showed this morning, you can do that directly in the Lambda console if you're going that route, which I don't recommend, but you can. Or you can handle it through the framework, the configuration in your framework, like serverless or whatever you're using. Things to also be very aware of are timeouts. I think by default, actually, the API gateway times out before your database, by default. So that's fun. If you're planning on doing a round-trip call and your database takes a long time, then you're host. So be aware of those. Also, native modules. Are there Node people here that use Node? Do you use native modules? No? Okay. There are people out there that do, and if you do, you need to be aware that that has to be compiled on Amazon Linux itself and not somewhere else, because it's going to run there. Serving static assets, we see a lot of small startups who are trying to do this sort of thing, and they've got assets being served back through the API, and because that's just how their mean stack generator set it up for them, right? That's bad for a lot of reasons, and it was actually very bad until recently because API Gateway didn't support binary. But now, since you're going to Amazon anyway, you're going to that infrastructure, might as well put it out on CloudFront or S3 or something like that that'll just handle it and serve your static assets for you. That bullet's old. Ignore that. It does support binary data now. Session state, obviously these have to be stateless. All these lambdas function in a stateless or need to be architected and assumed as though they're functioning in a stateless environment. They just have to. And if you're going to maintain state, you've got to do it in a database or something external that is going to persist. Your HTTP requests, if you're doing, let's say, a Node application with Express, and by default, everybody's used to doing the just listen at the end, you don't need that anymore. So you just strip that out. We'll see what that looks like in a second. And then we're going to export the Express configuration so Lambda handler can consume it, because the way that Lambda works is it has to have a handler that will then execute the underlying code. So that's pretty straightforward. If you want to go through a big bang sort of migration, there are ways to do that that Amazon has tried to outline for you using their AWS Serverless Express. We've toyed with that, but don't recommend it. If you look at Fowler's discussion about how to move these things, he says strangle it, which is a good approach, and we're going to actually do that in the demonstration later. And strangling it, does anybody know the term strangling it? Right, so what does that mean?
If you have a legacy application, you start by looking at specific parts of the application that would.
Thank you. So if you have a legacy application, you would be looking at specific parts of the application that you would like to rewrite. And you can use, for example, microservices or serverless functions for that. And all of your the remaining parts of the application will all be called out to these specific services. And then in the meantime, you can like strangle what's left of that, and it will always become a smaller part, so that you can have a completely refactored 12-factor serverless application.
Right. Exactly. Thank you. So we'll get into that in just a second. So, impact on workflow. One of the difficulties of moving to this sort of an architecture is that you now are heavily reliant on all the resources that you're using in your Lambda. So, if you're using SNS or something like that, then how do you test that locally? That can be a challenge, right? There is a tool out there by Atlassian called LocalStack that essentially replicates the Amazon API for you, so that when you're running your testing locally, you can call the LocalStack version of it, and it'll give you the appropriate response. There are other tools in there, including Azure CLI and the Cloud Functions emulator, that will help do some of those things similarly. But it's still not as clean as I would like to see it. I'm just not realizing, I think we're looking at an old version of this. I apologize. But I'm pretty sure that this is an old version. That's unfortunate. I think we might have to. All right, well, while we're taking care of this, has anybody actually tried serverless, doing something in serverless? Can you tell us a little bit about your experience? Well, you just talked. Can you tell us a little bit about your experience?
Yeah, it worked perfectly well with subscribing to SQS messages and then doing some sort of processing in Lambda function and then putting those messages back to SQS or Kinesis. That part worked well. I guess there are limits, 5 minutes lifespan, right? That's a big one. If you start consuming lots of API functional calls, right? Like I did, putting data into CloudWatch, I easily exceeded 800 messages per second. That has to be elevated and cannot be done in programmatically.
Mm-hmm.
And also, if you stress the rest of your cloud infrastructure, you may get throttling exceptions as well. So you have to find ways of playing nicely with other components of your cloud, right? And also certain constraints when you have hefty application context, right? And you may have to initialize some hefty components, like let's say you could do some wild things with encryption, or you have to initialize DOM objects or something that would not be appropriate for Lambda functions at all.
Yeah.
So you have to pick and choose your targets in there.
Yeah, absolutely. Anybody else want to share? Are they coming to switches? Yeah. Okay. Yep.
So most of the regular kind of applications, they go through a life cycle, right? You have it on dev, test, QA, staging, prod. How do you emulate such life cycles for Lambda kind of applications when we build on top of Lambda?
Yeah. So this is one of the issues that I was talking about that can be a challenge, right? It was funny hearing Christopher this morning say, "Well, just build it. Just do that. Like you have this infinite infrastructure available to you, so just copy and paste prod as a if you're using a SAM definition or a Cloud Functions definition, or in our case a serverless definition, literally just copy paste and it'll spin up and there it is, right? It's a direct copy. We haven't taken that approach, but it makes sense, absolutely. I don't see why you couldn't.
If you want a CI/CD kind of a pipeline, you just write your custom script.
We're gonna get to CI/CD, yeah. So CI/CD has been, and we're kind of skipping ahead, but no, it's okay. I'm just gonna plow forward, I think, with the old version, and thank you. So just to finish this slide, separate your context from your business logic. So the handler code, and Christopher actually showed an explanation of this morning, and we're going to actually not see this in the demo because I wanted to keep it simple for everybody. But separating the fact that you are a Lambda function being called by an API gateway, separate that out from your actual work that you're doing so you can keep things testable, right? And then mock if you must, but if you can, when you can. So this is Amazon's answer to that problem. The problem of how do you handle a CI/CD architecture in this environment. They have a tool that they just came out with, or a tool chain that they just came out with that addresses all of that. Some of these have been around for a while. whereas others, this is fairly new. Code pipeline, I think, is the new one. So they give a good example in AWS Serverless SAM Farm. I recommend you check that out and go through the experience of using that. There are other tools out there that you can do this, but you don't have a true CI/CD unless I suppose you could set up Jenkins to use the command line or something like that, but there aren't tools out there. For example, Circle CI or CodeShip or those don't really support this yet. We're actually building a product, serverlesscicd.com. We're building that to try to address this problem, because even if you do use AWS's tool, that's just AWS, right? What if you want to have AWS and Google Cloud Functions?
That's one other related question. How do we avoid vendor lock-in with Lambda? Is there anything emerging in the market that's neutral? Do you build things in a very neutral manner sometimes?
Not really. Not yet. I mean, there are the ones where you can roll your own, right? That claim to avoid or minimize lock-in, but I don't think there's no silver bullet there. I don't think. So things to watch out for. We've discussed some of these already, right? The fact that you're dealing with you're an entirely stateless environment within Lambda itself. Cold starts. We haven't really talked about that yet here, but cold starts are a byproduct of the fact that your function is running in a container that has a finite life, and it's not really up to you how long that life is. AWS will keep it alive if it needs to keep serving requests, but after a while it'll kill it off, and so you can't really expect that anything's going to be there from call to call. So something that was hard for us to get used to is you can't just SSH into the machine. Like that's so frustrating at first, but it's actually better, right? From a good practices standpoint, it's probably better. So you don't really have that access. It's something you just get used to. Your logging is handled by default. It's handled by CloudWatch. There are other tools out there like IOPipe that are starting to fill the gap there and bring a more centralized view to things. It's actually a very good tool if you're interested in that. Check out IOPipe. Language and version lag. So if you're developing in our world, it's the latest version of Node is 7 something. The latest LTS is 6 something. The one that's supported right now by Lambda is 4 something. So you just have to be willing to accept that. And then of course vendor lock-in, which we've talked a fair amount about already. So the specific limits as far as how many requests you can handle, how much memory you can take up, how big your Lambda package can be when you upload it, all of that you can find here at this link. I didn't put all of these up here because it would just be information overload. You can look this up pretty quickly. Microsoft is not so much TBD as it is depends on what pricing plan you're on. They have different pricing plans, and so they have different limits. So the workshop portion of this. So if you ask Amazon, what are some great use cases for your technology, they'll point you to these 5 design patterns. So, and not only do we have these as pretty pictures, but also they've built these out so that you can pretty much hit a button, deploy them, and see how that all works together, right? So in this case, this is an event-driven data processing example where users uploaded images and notes, and then that upload is the trigger to kick off some processing in Lambda that then dumps things out into S3 and DynamoDB, which itself then can be a trigger for something else, potentially. In a web application scenario, this is an example where there is mobile voting going on that then it hits the API gateway, which kicks off a Lambda function that does some tabulation and whatnot, dumping results in DynamoDB and kicking out some static results that can be then viewed online through S3. Another example might be a mobile application. I'm not going to walk you through all of these, but you can take a look at the down here the reference architectures link. That's a link to all of these, and you can actually just go through and see which ones are closest to your potential use case. Click through, get some details on them, and then just fire them up. It's really quite simple to do. So, when you're thinking about does this fit my use case, you can use one of the reference architectures. You can also model things out in a CloudFormation template, for example, thinking about what the different resources are that you're going to need. You can pair that then potentially with a step functions map. Who knows what step functions are? Anybody been exposed to step functions? Okay, it's essentially a state machine using all of your lambdas, and it allows you to build a visual representation and then execute that representation. It's a way of orchestrating your lambdas. So this is another way to think about how these might work together, the lambdas as well as the resources and events, to create your full system. I have reactive programming in there because a couple different reasons, but one, did anybody see the talk by the Capital One team about their reactive programming, how their microservices lesson learned? They use a reactive programming model, and I think we don't currently do this, but I can really see an application for this where you're using reactive modeling and using like a framework like Chaos put out by Cornova, where you have hundreds, maybe thousands of lambdas that need to behave somewhat autonomously and really interact based on the inputs that are present. And you don't need to make a deterministic state machine for each one, or how they need to interact. They just, when they see their inputs present, they fire and return whatever results they get. And it's an interesting model. It doesn't directly apply to our world because, as I said before, we do a lot of simple web type stuff. But it's a very interesting approach for especially like autonomous IoT type things. So if that's in your area, you might want to check that out. IOPipe, I mentioned earlier, as far as monitoring and logging, that's a tool that brings together a nice dashboard and gives you a lot of insight into what's going on in your Lambda functions that you might not get out of just CloudWatch by itself. This is kind of, we did cover this. This is a bit more refined version of it. It introduces the idea of orchestrating using AWS step functions, but this is a more refined version of the Greenfield build slide that we saw earlier. And we've already talked about this. And yeah, the one that I said binary is not supported is removed in the final version here. I hope I get some credit for that. All right, impact on workflow. So when you think about workflow, these are the 4 steps that Amazon recommends, and I think it's a good template to follow. Modeling your application and infrastructure resources, so thinking about what you're going to have to deploy when you actually get up into the cloud. Configuring your multiple environments, dev, prod, etc. Your testing and validation model. This, by the way, I should say that this was part of their sales pitch for the whole code pipeline solution, so take it with a grain of salt. An automated delivery process, that was all part of their pitch. But it's all perfectly valid. It's just that the tooling, aside from the one that they were selling, isn't really mature out there yet, so it's hard to do this other than with their tool that they're selling. So we've seen this. I think the one caveat I have on here is as far as testing goes, make sure you check out if you're going to use a framework. Frameworks treat testing differently depending on which framework you're using. So make sure that you look at those details. Serverless has some nice plugins to help you with that. that we like. So we recommend that. But so if we look at the sort of old world of way of doing things, which kind of touches on your question, you know, you write code, you commit source control. If you've got a CI server, it notices that check-in, it pulls it out, runs the test. Everybody here should know the routine, right? This is typical basic DevOps in the old world. But you have these new things that are relevant to the serverless infrastructure events and the different routes that need to be set up, as well as the resources that are used. So how do you deal with that? Which leads into the slide we've already seen. Right now, Amazon's solution is this code pipeline tool. All right, I think we've seen this. And then the added one here, I believe, is the no clear solution for cross-cloud, right? So specific limitations, I guess I should point out. On the previous version of the slide, we didn't have this, but essentially the resource limits, concurrent execution, and deployment limits are the main things that are of concern when you're dealing in this world. And now we can get into the workshop. So I hope you follow along. Essentially what we're going to do here is set up a traditional N-tier application. It's going to be a basic Node server and React front end. And we'll see what that looks like in a minute. We're going to set it up, get it running, make sure that you've got it running on local, and then we're going to take that and strangle it and try and get one of the routes up running through Lambda and see what that's like. This is really meant to just get your hands a little bit dirty and see how this might work. So we need lines and boxes. This is an architecture conference, so you got lines and boxes. And it's not particularly pretty, but it's just meant to convey the idea that you've got your local host running your two servers that are serving your client and your server respectively. And then they're calling out to a database I set up on MLab just because it's easy and everybody can hit that and we don't have to worry about server databases. So let's get started. Start off by cloning this guy. This guy is going to be your back end. And by the way, I would be doing this live, but I was under the impression that I was talking to a static slide deck, so that's why this is this way. Otherwise, I would be doing it live so you could follow along in person. And while people who are on their laptops are doing this, people who don't have laptops, you have questions or concerns? Yeah.
So are there patterns and practices that are evolving in this space? You know, like last year, everyone was raving about microservices, and then this year they're talking about here are all the gotchas and here are the practices. And same way, you know, serverless architecture. What are the side effects? How do you deal with those side effects? Because I'm like sitting here thinking about what about my, let's say something very basic.
Yeah.
If I had an API that took a call, made a couple of function calls internally between service providers and called some couple of repositories, right? And I could decompose that into, let's say, 3 or 4 function calls. There was an implicit assumption that a front end, the API receiving it, had established some security context. You don't have to revalidate OAuth tokens, for instance. Now,
Yep.
every function is by itself. So now there's a side effect that today, for every one API call, I make one call to, let's say, Azure AD to say, hey, is this token valid? You know,
Yep.
now, is it turning into 3?
Yep.
What's the resultant impact?
Yeah.
Because in a business application, those things are important. You cannot just let someone call your function if it's like, so you get the point.
Yeah, I do. It's a good question. As far as is there a perfect answer? No. But with the example that you gave as far as authorization, AWS does provide for an authorizer that you can define. In serverless, the serverless architecture makes it really simple to just specify what that authorizer is, so that every time one of your functions gets called, it passes through the authorizer first. and if they're not authorized, you don't get charged. It doesn't execute. So that's one saving grace. But you really do need to rethink your entire application. I purposely made our example really simple because if we were to do a full-blown migration, you have to rethink a lot of things, and it takes a lot of work and a lot of time. But it's maturing, and so there are the things like the security example is one where they thought of that. They've got it covered. But as it evolves, it'll get better. I don't have a better answer for you than that. Yes.
So it's I
Four.
guess.
Is it? Sorry. Okay. Sorry.
Thanks. I guess it's a simple question. When I kind of sit and listen to folks that say, you know, you could put your web traffic through the Lambda functions, knowing that Lambda functions are not HIPAA compliant, right, means your privacy is not actually guaranteed, at least as of now. I'm almost scared to think that some websites which I trust may be using Lambda functions, right, and pass my credentials or account information or details of my transactions through Lambda functions. How you guys address those challenges?
That's perfectly valid, and the answer is if it's a concern, don't do it. You don't need to do this, right?
Yeah, but you are in the web e-commerce business, right?
Yeah.
And you do something, you pass some sensitive information, I presume, through Lambda functions, right?
Yes.
So how you guys do it in a secured way?
How do you do it in a secure way?
Yeah.
Using HTTPS? What do you mean?
Well, if my data, my personal data, goes through your Lambda functions,
yeah.
What exactly you do to preserve the privacy? And I guess.
Well, I will start off by saying we don't do anything like HIPAA compliance. We just don't. That's not in our.
But if you run banking transactions, right, you're
yeah.
kind of facing the same challenges.
Yeah, I wouldn't run banking transactions through this.
Okay.
Not yet.
Just like you have apps running on VMs,
yeah.
you expect providers to make sure that your VMs are isolated. Similarly, the isolation boundary is managed to the provider. I think that's what he's really.
So he's asking, do you trust Amazon? You're saying?
What amount of security things that you expect your provider to take care, and what is it that you would build on top of what the provider supports?
I would expect it to handle things like transport layer. I would expect it to handle inter-process communication security, but when it comes to application level, that's up to us. We're writing the authorizer.
It's a shared responsibility model.
Yeah, yeah. So are people having issues? What with demo? So for those of you who've been wanting to learn React, this is a good chance to dig into React. This is an example that I found out there. It's sort of pre-packaged solution that can be interesting for you if you want to get into the Node world and React and all of that, full stack JavaScript. But it also means it's really easy to just quickly spin up in a demo, theoretically. All right, we good? Does everybody have that? Have which? So it should, when you run start, it should kick off your browser and bring this up. And if it doesn't automatically do that, it will have redirected the port to 3001 instead of 3000 because the backend is running at 3000. So if you want to bring it up manually in the browser, just do localhost port 3001. Okay, I'm going to keep moving. And we'll try and resolve these issues after everybody else has kind of kept going. Is everybody else up and running? I think we have 2 people that are not. Everybody else up and running? Yeah, for the most part. Oh, I think it will run on 6. Or actually 4. It should work on 4. Either way, it doesn't matter, actually. It's not using anything special, I don't think. Okay, so assuming you got this far, which is not a guarantee apparently, maybe we should have Dockerized it and just had everybody. I realize that now. So now we're going to try and strangle this, starting with tags, and see if we can get that part up into Lambda easily and quickly. So what that's going to look like is we're going to have our 2 servers still running, our legacy system. We're going to have AWS serving the API gateway that we're going to hit for the tags API. That's going to then go back and hit the tags function running in Lambda. It's also going to hit the SATURN DB, which is also serving the Express API from our legacy. So to do that, let's create a new project directory. Keep your server running. Keep both servers running. Create a new project directory. Let's install the serverless framework. Now, the nice thing about the serverless framework is that it provides sort of pre-packaged templates to allow you to do quick and easy deployments. It gets things kind of set up for you. It scaffolds it out a little bit for you. So we're going to use the AWS Node.js template. In serverless framework parlance, a collection of Lambda functions and resources that those functions use are called services. So we're going to create a new service in the serverless configuration. So I told you this is an exercise in NPM installing. So you're going to another NPM install. Once you've got the serverless template created, simply go in and modify the serverless YAML file, uncomment lines 64 through 67, and then add a line for the CORS configuration. It does a lot of heavy lifting for you in the background that you don't have to think about with this little bit of code. 64 to 67, then you're going to add another line for CORS. Sorry? No. No, all you want is events, HTTP, path, method, and then you'll add CORS. Yes. Depends on if you're dyslexic. 6, yeah, that's true. So one thing that we didn't really talk about, but what's happening kind of in the background here is it's going to go out when you do the deployment. It's going to read this. It's going to go out and it's going to configure your API gateway. And there are a number of ways that you can do that, either through a framework like this, or you can actually do it in Swagger, which is a good option if you want to do a migration. I strongly recommend taking a look at just creating a Swagger file based on your existing API and uploading it. Or you can go through the UI, which is incredibly painful in my opinion, but you can do it. And this will do all of that for you. And it sets up all the configurations and stuff, which can be a nightmare through the UI, especially when you're dealing with things like CORS. Now, that's really all we have to do from a configuration for Lambda deployment standpoint. That's really all we really have to do to configure things. Now we're just going to go in and modify our code so that it's appropriate for Lambda. So in the handler, and you don't have to write this, please don't try and copy this, I created a paste bin here that you can use. But essentially all we're doing here is creating the Mongo connection. This is going to be the handler that runs in Lambda. And in best practice, this would be a separate library that the handler would call, but I just wanted to have it all in one place so that we could just copy paste. So your hello, which if you look, which I don't have a copy of here, but if you look in your serverless.yaml file, it actually specifies what the handler is, which is the function that is called when your Lambda function is kicked off, bootstrap, whatever, like actually called. So this module exports hello, you'll see there in that YAML file, and that's this function. This is your whole handler. So we're going to connect to Mongo. We're going to search the database for tags, and then we're going to create a custom manufactured response so that it goes back through the API gateway appropriately. Go back one.
So we replace the content of handler.js with the paste?
Correct. Yes. You replace the entire contents of handler.js with the paste bin.
When you say the API gateway, you're referring to the React app.
No. No. Sorry. So here. Your React app is just sitting on your client, or it's on your client, right? The React app is being served up by your legacy web server, whatever it is. In our case, it's Webpack. That is then going to call, for most of your page, it's going to call the Express API, the legacy Express API that's being served up by your Node server, right? But for this route, we're telling it, okay, now we're slowly moving to Lambda. For this bit of information, go through the API gateway, which is an AWS service that sits in front of your Lambda.
So we're going to be setting up the API gateway as well.
You did by virtue of doing this. This is all you have to do if you're using the serverless framework. If you do it manually, it is much different. This is why we like serverless. It does a lot of heavy lifting for us. This is why we like this framework. And that's a fairly deep rabbit hole, actually. And when you need to get into more advanced configuration and different kinds of request response cycles, you should investigate through the UI and see what all your different options are and everything. It's fairly involved, but for a simple example like this, that's all you need to do.
So path tags, that's the API call, I guess.
Yep.
If I wanted to have tags slash something else, I would just put slash slash slash
Yep.
in the path.
Yep.
And the method was where the data is going to be in the get or the post, I guess.
Yep.
And what's cores?
Cores is your cross origin. So since we are doing this, we're serving the page from your legacy server, but we're asking the browser to go somewhere else for data. It's cross origin. So you have to specify that cross origin's okay. And you'll notice that in our code, we say we are allowing cross origin here. And we can actually specify if we wanted to, we can actually specify the origin. But for ease of demonstration, we did it this way. This could easily be localhost. Any questions? Everybody up to this point? Feeling pretty okay? Okay. Anybody need me to hold here, or can we move on? Hold on? Okay. This is our actual Lambda function. This is the actual code.
Yes.
Do you need to install MongoDB even though it's doing a remote call?
No.
You need to install the library it's the driver for Mongo that knows how to connect to Mongo. But you're not actually installing Mongo natively. In fact, you can't in Lambda. So in this example, I am not using the Amazon service for this, but if you're really trying to go full-fledged into the serverless infrastructure and take advantage of all of the things that Amazon has to offer by being able to trigger other Lambda functions by virtue of inserting a row or a record in one of their databases or something, you would want to use the Amazon version of this, not Mongo Lab like we're doing up here. Or whatever, yeah, or whatever. But the difference is, this MLab database, if, for example, this were a post or we're creating a new record there, if that were an Amazon database, that could then be a trigger to kick off another Lambda if you want to do post-processing or something like that. In this case, it's not. It can't be. Or you manually kick it off, right? Or you, as part of your state machine that you build out in step functions, then that's just the next step in the step functions. Like, there are so many different ways to do this. It can get really mind-boggling fast. So when someone asks, is there a best practice pattern? Not really. Like, there are just a lot of different ways to be able to skin this cat. I'm trying to give you the simplest one.
Sorry, you might have said it already, but in this example, we are actually running a dev environment, so we are actually running the Lambda function on our locally hosted
No.
thing.
No, but you can.
I can, but in this case, when I run this thing,
Yes.
is it deploying that on this?
It will. We haven't gotten there yet, but it will. So that's going to be the next step. We'll see what that is. But you can, to answer your question, you can absolutely invoke locally and do some testing that way. What's that? Yep. 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 Okay, are we good?
What IDE do you use? Whatever favorite IDE that works with NPM and
I've recently switched to VS Code, which I didn't think I would be using a Microsoft tool again, but they did a great job with it. Honestly, VS Code's fantastic. I'm really impressed. Okay, are we good? Sorry?
Okay, go ahead.
Good.
Just ready to replace.
Okay, so here is the deploy step. So I'm hoping everybody's got their Amazon CLI configured. Okay, if you don't, take a few minutes and do that. I didn't have a great way to give you this link, but you can quickly just Google configure Amazon CLI. And the short answer is you have to just do AWS configure, but then you've got to get your tokens and all your information to plug in there. So take a few minutes and do that if you haven't already. If you have, go ahead and do a serverless deploy from your Lambda directory. So what's happening in the back? Well, it tells you actually what's happening in the background. So it's going to bundle up all of your code, all of the dependencies, everything. It's going to zip it up, throw it up to S3, and then deploy it from there into a CloudFormation stack, essentially. When it comes back, it will give you where it deployed it. By default, it goes to a dev stage. And you can set up different stages in your serverless configuration, but for simplicity, we just left it to the default of dev, and it also defaults to US East 1 if you don't specify, but you can specify that too. And then it'll give you your actual endpoint for your API. And you're going to want to hold on to that. It can be wherever you want it. This will deploy to your account, by the way. Be aware of that. So you are putting your own code up somewhere in your account. So are we good to move on? Does anybody need to stay at this point? Raise your hand if we need to stay. We're good to move on? Okay. So if you got your Lambda deployed, you should be able to hit that URL that it gave you back, and you should see a list of pizza toppings. Anybody? Success? Failure? Confusion? Sleepy? Bored? Signing up for Amazon? Oh, shit. Oh, that may be the best response. I don't have an Amazon account. Oh. That's totally reasonable. Something I hadn't considered. Okay, so the last step here is then to take your Lambda URL, plug it into the front end so that when instead of grabbing the local tags, it's actually grabbing it from Lambda. There's a little bit of code you can actually see from above, but it's basically just this. In the source agent JS, update line 44 or 43. So it hits your Lambda function, and that should be it. Now you have moved functionality from your legacy application to pull data and run through Lambda in AWS. Which one? Right here. In source, agent.js. I think it's off.
I think
Oh,
it's.
there it is.
Any more questions?
So I know this was a very simplified version, but I was doing that on purpose to try to make it demonstrable, but and to just get your hands dirty and feeling what it's like to work with serverless. Use the serverless framework. I strongly recommend it. It does a lot of heavy lifting for you.
That URLs. I'm not set up with AWS CLI, but once you set up and push a Lambda instance, it'll give you a URL.
It will.
And it's not going to be the same as yours, I assume.
No, no. It'll be your own. It'll be your own. Yeah.
And as you said, I think as the other gentleman said, there's nothing to prevent someone from spamming that.
Currently, no.
Right.
True. I take that back. You can have the authorizer in place, right? So, but that only limits access. It doesn't prevent a DDoS or something.
Could you set up the API gateway to only allow access to the URL for authorized users? In other words, it won't even expose the URL?
So like using an IAM profile or something like that? I don't think so. I don't know. Any questions? Yeah.
So
Okay.
in regards to this serverless frameworks, in the context of enterprise projects where you have many people working on them, they live a long time, they may be running in maintenance for a while with not a lot of attention. Do you have challenges around sort of keeping up with the framework itself?
Yeah, I'm sure, yes. So I can't speak to this specifically because this is all very new, and so there hasn't been a lot of evolution. There hasn't been a lot of time for things to evolve, but yes, it changes all the time. So I would assume that you can expect a lot of evolution going on here. Yeah, and quite honestly, in an enterprise, big enterprise type environment where you've got long-lived assets that are going to be out there and running, and you've got to maintain them, you're probably going to mature past the serverless framework phase pretty quickly. You're going to be creating your own CloudFormation templates, or in this case, SAM templates, serverless application model templates, that are going to manage all of your deployment information for you, your infrastructure as a code. So it will only get you so far. So I think it'll get you started down the path, but eventually you'll probably grow out of it.
Okay, then I think it's time. So break and the last run for the afternoon.
Okay. Thanks, guys.